So if there's 4 points in space, you have 4 points. The contour is made by triangulation. So the computer is going to find the contours that go through these lines. But here's the problem. You have 4 points in space. What if these same 4 points was joined this way? Now you have two completely different surfaces. So what a breakline does, it's a line that tells the computer which of these two surfaces to make. And that has to be done by someone by hand. You can't just press a button in the computer and it automatically knows where break lines are. Math doesn't work that way. So someone has to manually guide the contour, say this is the way it goes, it's not going this way.
These are points from a land survey for the Land Mentor training. Now, if we go to reports and look at the elevations, they're random elevations as would be in nature, and then this shows you what the descriptions are. So in other words, center line of creek should be connected to center line of creeks and top of banks and stuff like that. So when we look at this, a unique aspect of Land Mentor is to limit points by descriptions. So if I wanted just the center line of creek, I could move those over by description, and then on my center line layer, I would just go into make line and define a break line so that the center line of creek is a topo will follow the center line of creek. Now, there's a few things to be aware of. There's things that are what we call cross sections. So if I take limit pipe descriptions and just say show all, you can see cross sections as surveyors typically do when they cross a road. They'll do bottom of a asphalt, the center line, and the edge of the asphalt. So it forms a topo through there. And as long as they do cross sections or close to cross sections, it should come out just about right. Here it's kind of random, so we're going to get the same thing here. There were no cross sections. It was kind of random, and that's where the problems occur. So for ponds and for things that are random, it's really not going to know how to connect. So when I go to topography and I create a digital terrain model, now, as you can see, it follows the center line of the creek. Now I've saved that away, and you can see the road cross sections are kind of right, but it took this point as influence. Now, that wouldn't have if I had the edge of pavement design, because that would create a break line. This pond, here's a point in the pond. It didn't have a pond definition. Now, we could go through later and then edit the surface. So if I go to topography and edit active triangles, I could take and just, when we look at the right, click to the nearest point for the edge with my middle button, and then define a new edge. And then it will change it. As you can see, now the topo doesn't go across. So we could define it, but that's kind of tedious to do it afterwards. And you can miss a lot of detail. For example, this little hillside going into the pond, that contains area for earthwork and stuff like that. So you really want to pay attention to these elevations and manually do the break lines. Now, another example is this topo. So you're looking at a creek through here. Now, these are contour lines created by AutoCAD. This is not a DTM. These are actual contour lines by someone that didn't define any break lines. And this is the center of a ditch, and these lines go everywhere. And why? Because the break lines weren't defined. And because the break lines weren't defined, someone that doesn't know what they're looking at, maybe this went to an architect and they start designing things and they misinterpret things. So it's very important before these topos are handed off to anybody that the definition of those are correctly done with break lines. Same thing through here. This is a ditch. You see these little holes here? That's actually a center of a ditch going to the center of a ditch going to the center of a ditch. That is a very deep ditch, but you wouldn't actually see that. Same thing here. This doesn't do this. You can see these are 2-foot contours. This is a massive amount of earthwork getting wrong because here's the top of bank, here's the top of bank, here's the top of bank. And what they're doing is they're picking up very low points. They're picking up maybe the flow line of a very deep ditch from out here because there was no break lines here. So it's very important to get this stuff done right. These purple lines are a very different type of break line. What happens in the computer when it generates the triangles, it's going to look at same elevation as a flat spot. So in other words, this area here is going to be the flat spot, and then it's going to triangulate differently, and you're going to have flat spot, some contours, flat spot, contours, flat spot, and contours. So this is called connecting the noses. And so this is a different type of break line that we do on different sites. Now, there's no noses here, so that means these are essentially the same elevation, or just we didn't do them. So again, we would have to do a make line and then connect these areas here so that they define the contour going through those areas. So if I turn off the turn off the line work, so I'll just deactivate all layers. I'll say inactive, set all, and then do the topography. I've already created a digital terrain model through here. So you could see these areas here may not exactly be perfectly right, but these areas here are, because we took the time to define the break line. So there's a very large site like this, a couple thousand acres that were, millions and millions of points on the original LiDAR. We've reduced it to about 70,000 points with about the same accuracy. So it didn't matter if it was 4 million points. If you didn't connect the noses, you will get the wrong contours and you will get the wrong areas. So break lines are important that way too.